Well, hello guys and welcome back to Mr. G Physics, the channel that is going to help you to improve your marks in physical sciences. Here is Mr. G and this time we're going to be solving a question on electrostatic for the grade 11 and 12. This one was question 7 from the June 2023 done in the Northern Cape province. The question said two charges A and B of positive 3 microcoulomb and negative 5 microcoulomb respectively are placed 15 millimeters from each other. Point P is a point 20 millimeters right of charge B, as you can see there, guys. Question 7.1, define electric field strength at a point. Okay, so what is electric field at a point? Is a force per unit positive charge placed at that point. Guys, that is the formula and also the definition for electric field at a point. Question 7.2, calculate the net electric field at point P. Now, what is happening at point P? The electric field due to charge A is going to be to the right. Why? Because A is a positive charge and those points is like a positive charge was placed at that point. So the electric field due to charge A will be a vector pointing to the right. This one is what we call EA. So that is the first important thing. Second, for B, now is negative. If we place a positive charge at point P, it will be attracted by B. So this one is going to be EB. There we go. So we have EA and EB. Now remember, the net electric field is the vector addition of the electric field of all the different points. So we have the electric field A plus the electric field B. This one is a vector addition, so direction must be taken into consideration. Now, what else is important to know here? The distance is given in millimeters. We cannot work in millimeters. We have to convert. So this one is 0.05 meters, and here is 20 millimeters. We also don't work with that one, so it's 0.02 meters. What are the important data here? The charge cannot be in microcoulomb, must be in coulomb. So this one will be 3 times 10 to the minus 6 coulomb, and this one here will be minus 5 times 10 to the minus 6 coulomb. We're working with coulomb. So we go now to a new page. We're going to answer that question here. This is question 7.2, and we're looking for the net electric field at that specific point. It's the vector addition. Remember that one. Okay. So now we have to calculate the electric field of each of them separated. Electric field A is equal to K charge A divided by distance squared. Now distance A, if we go back here, remember it's from A to the point, so it will be 50 millimeters plus 20 millimeters, which is 70 millimeters. So be careful with that one there. So we come in here and we substitute all the numerical values we have here. The answer here is going to be 5,51 times 10 to the 6 Newton per coulomb. Now, if we go back here, the direction, we can include the direction. It is going to be pointing to the right, as you can see there, guys. Okay, so this one is to the right. I don't need this one. I just need it because I need to use direction just now. For EB, the same formula, we just change the charges and the distance. So we substitute. Now remember, during this substitution you do not substitute the signs in this specific formula. Okay, so only the magnitude of the charges. So here we get that this one is 1,125 times 10 to the 8 Newton per coulomb, and this one, if we go back to our drawing here, it went to the left. So this one is left. Because we have different directions, we have to select which one is going to be our positive direction here. Okay, so let's say here right is positive. Most of the time people use right as positive, so it doesn't really matter, but let's use right as positive. So E net, let's do it at the bottom here. E net is equal to EA, which is positive because it's to the right, so it's 5, let's have the vector notation, comma 51 times 10 to the 6 plus minus 1,125 times 10 to the 8. And then here we are going to calculate. The final answer is going to be negative 1,07 times 10 to the 8 Newton per Coulomb. That negative means to the right, so to the left, because right is positive. So the net electric field is equal to 1,07 times 10 to the 8 Newton per Coulomb left. Guys, this is the answer. How we give marks here? We give 1 mark for the formula of calculating electric field in the non-uniform electric field. We get 1 mark and 1 mark for the substitution of those two electric field A and B, 1 mark for subtracting here, and 1 mark for the final answer. This is 5 marks for this question, and it's quite simple to get those marks. Question 7.3, a point charge of 1 nanocoulomb is placed at point P. Calculate the magnitude of the net force experienced by the 1 nanocoulomb charge. Guys, if we have the net electric field at this specific point, remember we know now the net electric field here. We calculated. We're using this definition, therefore we can calculate the force. Quite simple. So if we have that the net electric field will be equal to force per unit charge, but this one will be net force placed at that point. So this is the formula we are going to use. The net electric field is calculated by us, which is 1,07 times 10 to the 8. We're going to use that one here. We're going to substitute. This one is 1,07 times 10 to the 8. This is equal to, this is a negative electric field. Remember that negative means direction. So we come here, F net divided by the charge, which is going to be charge at that point, which is going to be 1 nanocoulomb, or 1 times 10 to the 9 coulomb. We get that the net electric field, or net electric force, they're looking for magnitude, is equal to minus 1,07 times 10 to the 17 Newton. But this one means direction. They don't want that. They want the magnitude. So the final answer is F net is equal to 1,07 times 10 to the 17 Newton. This is the final answer. 3 marks for this one. 1 for the formula, 1 for the substitution, 1 for the final answer. 3 marks. Guys, thank you for watching. I hope it helped. If it helps, some up, subscribe for the channel, share the video, like it, and I'll see you next time. Mr. G